Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's a problem for today for exam LTAM. For a fully discrete 10-year term insurance paying a death benefit of $1 million on the last death of 50 and 60, you are given the future lifetimes of 50 and 60 are independent. Mortality follows the standard ultimate life table. Interest rate is 5%, which is the rate in the table. Premiums are paid annually, reducing by half on the first death. Calculate the annual premium payable while both lives are alive. So the premium basically is such that there's a half of the premium paid until the first death and half of the premium paid until the second death. And here's the solution. So let us write P for the premium side. The problem does not explicitly say this, but we are expected to know that the premium is calculated using the equivalence principle. And that means that this $1 million term insurance with death benefit payable upon the second death, present value is equal to P over 2 times A double dot 50 colon 60 colon angle 10 plus P over 2 times A double dot 50 colon 60 colon angle 10. So this term insurance here is kind of the painful part of it, and I can't come up with a simpler solution. It's not terribly complicated, really. It's just that it's calculation. But anyway, we don't have these second to die actuarial present values in the table. We need to find them in some way. And there is the second to die term insurance. And it is equal to second to die whole endowment insurance minus 10-year pure endowment on the same status, which is 50 colon 60. And so I write it as this 10-year endowment minus pure endowment, as you can see. And then I use posttix to write the 10p 50 colon 60 with a bar above it as 10p 50 plus 10p 60 minus 10p 50 colon 60, because 50 and 60 are independent. Then this is equal to a product of the two. So this is equal to A 50 colon 60 with a bar above the 2 colon angle 10 minus, now there's 1.05 to the negative 10th multiplied by 10p 50 is 10e 50, which is in the table, multiplied by 10p 60 is 10e 60, which is in the table, multiplied by 10p 50 again is 10e 50. If we had another one to multiply, then we could write this also as 10e 60, but we don't, so we have to make up for using another one by writing its reciprocal, which is 1.06 to the 10th. And now all of the values here in the table, I'm just leaving the pure endowment term alone because I'm going to find it from something that is in the table. So all these numbers, we plug it in, do the calculation, and this is approximately equal to A 50 colon 60 with a bar above it, angle 10 minus 0.6132184. Now, using David Ricardo formula, we have A 50 colon 60 with a bar above it, angle 10 equal to 1 minus A double dot 50 colon 60 colon angle 10. Note that A double dot 50 colon 60 colon angle 10 is in the SULT table, and its value is 7.9044, but A double dot 50 colon 60 with a bar above it angle 10 is not, and we must use posttix to find it. So it's equal to A double dot 50 colon angle 10 plus A double dot 60 colon angle 10 minus A double dot 50 colon 60 colon angle 10. So we plug in those values. This is equal to 8.1061. And the premium must be equal to 2 million times A 50 colon 60 colon angle 10 with a bar above 50 colon 60 minus 0.6132184 over A 50 colon 60 colon angle 10, I'm sorry, A double dot, plus A double dot 50 colon 60 with a bar above it colon angle 10. Now, of course, the 2 million, the million becomes 2 million because we take the 1/2 from the bottom and it becomes 2 at the top, and it's multiplied by a million. And now we use David Ricard, the numerator, and postx in the denominator, and this becomes 2 million times 1 minus d times A double dot 50 colon 60 with a bar above it, angle 10 minus 0.6132184 over A double dot 50 colon angle 10 plus A double dot 60 colon angle 10. And the d is, of course, 0.05 or 1.05. We found the value of the annuity A double dot 50 colon 60 bar colon angle 10 to be 8.1061. And the two terms in the denominator are in the table, so we just look them up and plug them in. When we do the calculation, this comes out to be about 97.0357287, and that's answer E. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.